Salutations, mini mathematicians! Hope you're having a fabulous day. Today we're going to be working through 6.2f, solve equations and using square and nth roots. It's going to be on a printout, or maybe you're working on this in your notebook or on a separate piece of paper or on a touchscreen PDF. Let's get started. So the purpose of today's lesson is we're going to be solving equations by simplifying and or undoing a radical expression or power, like an exponent. Again, we're solving equations, so we're going to isolate the variable using inverse operations. We're going to identify when an equation has no solution, one solution, or two solutions, and we're going to really focus on verifying, because sometimes you can go through all the inverse operations and you'll actually get a value that's not a solution. So remember way back in Module 1 when we talked about how many solutions an equation can have and what the definition of a solution is. And then we revisited that definition in Module 4 when we were dealing with systems of linear equations. So a solution or a value, a number is a solution to an equation if that value or values, if there are any, when substituted in, make that equation true. So like I said, today you might start doing some inverse operations and get a value that when substituted in does not make the equation true. So you have to be really careful about our solving process steps and notice if we end up with a statement that's actually a false statement. Remember that if we have an even index, the square root of any number or any even index root of a number can never equal a negative number. So you might end up with something like that in your equation, and then you'll know there's no solution. There's no value that will ever make this statement true because it's a false statement. Or if we have an even root of a negative number, that can never be a positive or a negative number. So if you end up somewhere with an even root of a negative number, there's no value that's ever going to make this true. Also, I always want you to remember to always isolate the radical or exponent expression first, and then to undo that operation. And that's going to be really important so we can follow our order of operations. Awesome. So let's get started. Hopefully you have the document ready. 6.2f lesson. So what does an inverse operation do? Do you remember? What do you think? Yep, you're right. An inverse operation undoes an operation. Undoes an operation. Perfect. Okay. And we always want to be thinking about undoing them in a proper order. And it needs to be done. Inverse undoes an operation can only be applied to, can they be applied to equations and expressions or just equations? They can only be applied to equations, equality property. Same, do the same, inverse operation, do the same to both sides. Just a little reminder from your 7th grade solving equations days. So let's see, consider the equation x squared equals 25. Is 5 the only solution? Is 5 the only number that makes this equation true when substitute for x? Explain your reasoning. Well, let's think about this. X squared is equal to 25. Does 5 make this equation true? Is 5 a solution? Well, 5 squared is 25, so yes, 5 is a solution. But is it the only solution? Can you think of another number when multiplied by itself you get positive 25? Yeah, negative 5. Negative 5 squared is also 25. So when you have x squared is equal to 25, the inverse operation of squaring is taking the square root. Whenever you're taking an even root, we have to think about the plus or minus being in front of here. So that x is going to be equal to plus or minus 5. So there's two solutions. But now let's take a look at the square root of x equaling 5. Is 25 the only solution? Well, what about the square root of negative 25? You can't take the square root of negatives. It's not a real number. So thinking about this, is 25 the only solution? How do you undo square rooting? That's right, you square. So x is only equal to 25. It's the only value that makes the statement true. There's only one solution. You cannot take the square root of a negative number. This is a yes. Cannot take square root of a negative number. Little shorthand notes there. Okay, so number 4. I'd like you to think about looking at number 4 and thinking about what inverse operation we're going to be using for each one of these, and also be thinking about when we solve, how many solutions are we going to have? And that's going to help you if you think about that ahead of time. So let's see, x squared is equal to 100. What's happening to your variable? It's being squared. How do you undo squaring? Oh, take the square root. Okay, so let's just go through and think about what the inverse operations are. Okay, B, x squared equals negative 36. How do you undo squaring? Oh, take the square root. Let's look at C. What's happening to your variable? It's being square rooted. How do you undo square rooting? Oh, take the square. Inverse operation. Oh, look at D. What's happening to your variable? It's being square rooted. How do you undo square rooting? Square both sides. So now I'd like you to go back and I'd like you to solve each of the equations. Be careful. You might have one solution, you might have two solutions, and you might have no solutions. So I'm going to have you pause the video real quick and go ahead and finish solving those, and we'll check back in a second. Okay, let's see how we did. Square root of x squared is x. Remember, when you take the square root of both sides, you have to think about the plus or minus, because when I substitute back in 10 squared can be 100, but what else squared could be 100? Negative 10. So that's why we say plus or minus 10. And it's really important when you finish solving these to think about, is there another value? Could the negative also be a solution? Let's take the next one. X squared is equal to negative 36. We said to undo squaring, we're going to take the square root of both sides. Oh no! Can you take the square root of a negative number? You can't. So this is no solution. And maybe from the very beginning, some of your mathematical minds were thinking and you were like, what? Something squared is equal to negative? That's impossible. A negative times a negative is a positive. And a positive times a positive is still a positive. Fabulous. Let's move on to C and see how we did. See how we did? Okay, let's take a look. So, square root of x, we squared both sides. So that means x is equal to 81. And then pause. Could that also be negative 81? No, because you can't take the square root of a negative number. It's not real. Let's take the next one. Square root of x, we're going to square both sides. Okay, so x should be 64, because negative 8 times negative 8 is 64, right? Right? Please stop me. Yeah, you guys, think about this. This means if you substituted x and 64 back in, square root of 64, can that be a negative? No way. You really have to think about verifying these. So this one is also no solution. This pen's dead. Okay, so we're going to be moving on to now solving some of these equations. I'm going to do 3 of them with you, and then I'll give you a moment to finish the other 3. So I'm going to do 5, 6, and 8 with you. So let's start looking at 5. We want to remember, like we said in our notes before, always isolate the radical or exponent expression first. So here, the exponent expression x squared is already isolated. It's by itself, so we don't have to worry about that. And to undo squaring, I'm going to take the square root of both sides. I'm taking the square root of a negative. I can't do that. No solution. Maybe you're being a little bit of a math robot. Boop, boop, beep, beep. And you just took the square root of negative 64 and said it was 8. Well, then if you substitute 8 squared, would that be negative 64? Nope. Okay, let's move on to the next one. Number 6 says 3 times the square root of y is equal to 1. Notice this radical expression is not completely isolated. We have to get rid of that 3. Really similar to like when we were solving absolute value equations. The absolute value expression had to be completely isolated so you could drop the bars. So how do you undo multiplying by 3? Because that's what's happening here. The square root of y is being multiplied by 3. That's right, we're going to divide both sides by 3. So that means the square root of y is equal to 1/3. Totally fine. Square root equaling a fraction. How do you undo square rooting? Oh, you square. Whatever you do to one side, you have to do to the other. So that means y is equal to 1/9. 1 times 1 is 1. 3 times 3 is 9. Always think about substituting that back in. Square root of 1/9. Square root of 1 is 1. Square root of 9 is 3. 1/3. 1/3 times 3 is 1. Yes, feeling good. Feeling great. Let's look at 8, and then I'll let you work on 7, 9, 10, and we'll go over those answers quickly. So take a look at 8. The exponent expression, x squared, it is not isolated, so I'm going to need to subtract 7 from both sides first. When I do that, I will have 3x squared is equal to 90. Notice your exponential expression still is not isolated. I have to get rid of that 3. That 3 is being multiplied. How do you undo multiplying? Division. Divide both sides by 3 or multiply both sides by 1/3. And now you have x squared is equal to 30. Okay. How do you undo squaring? Take the square root. Notice this is an x squared. So whatever number I substitute for x, it could be positive or it could be negative. So from there, I'm going to be thinking plus or minus. So I know that x is equal to plus or minus 30, square root 30. Then you have to go back. Oh my gosh, the directions say simplest radical form. Let's think about 30 for a second. Are there any perfect square factors that go into 30? Well, if I look at 30, I know 30 is 2 times 15, and 15 is 3 and 5. So it's in simplest radical form. This is how I put my answer. X is equal to plus or minus square root of 30. Awesome. So why don't you go ahead and pause me and work on 7, 9, and 10, and then we'll go over them as soon as you're done. Thank you. Okay, let's see how we did. Number 7, undo squaring, take the square root. Remember that's going to be a plus or minus because some number when substituted in squared, positive or negative, you get the same value. So we have a is equal to plus or minus the square root of 1/8. This is not simplified all the way. We have to rationalize our denominator. So this is plus or minus 1/2 square root 2. Remember, we can't leave that radical 2 in the denominator, so I'm going to multiply by radical 2 in the numerator and the denominator. When you do that, you end up with plus or minus square root 2 over 2 times 2 square root 2 is going to be square root 4, numbers on the inside times numbers on the inside, which is plus or minus square root 2 over 2 times 2, which gets you your final answer of plus or minus square root 2 all over 4. Dun, 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 dun. 2 solutions there. And double check from the beginning. Does it have, the equation have a number being squared equaling a positive value? You know there's going to be 2 solutions then. So really careful with your work. Also, make sure you're rationalizing your denominator. Okay, let's take a look at how you did on number 9. Number 9, you needed to isolate your exponential expression first, so we're going to add 5 to both sides. So we have b squared is equal to 59 plus 5 is going to get you 64, which is so awesome because that is a perfect square. So I'm going to take the square root of both sides. Remember, this is some number being squared. A number and its opposite squared gets you the same number over here. So we have to bring over our plus or minus, just so we don't forget it. So that means b is equal to plus or minus 8. 2 solutions. Let's take a look at 10, the last one that you had to do. Here I have adding 4, so I'm going to subtract 4 from both sides to isolate my radical expression. When I do that, I end up with the square root of x is equal to 5. Totally fine here because I have the square root equaling a positive number. To undo square roots, we're going to square, which means that x is equal to 25. You're going to say, wait, Mrs. Barr, plus or minus? No, because here we don't have a variable being squared, we have a variable being square rooted. And can you take the square root of a negative? Nope. Okay, let's keep going. Okay, number 11, taking a look at 11, it says consider the equation x cubed equals 27. So now we're going to go away from square roots and squaring and start taking a look at cube roots and cubing. Do you think they're going to be a little bit different? Yeah, they are. Because now we're going to have an odd index or an odd exponent, and we really looked a lot at that in our last lesson. So is 3 the only solution? Is 3 the only number that makes this equation true when substituting for x? Yes, it is. Yes. 3 is the only solution. Odd number of factors of a positive number is positive. So you have to be aware of that. So let's take a look. I'm going to help you solve 12, 16, and 13, and then you're going to solve 14, 15, and 17 after we do these together. So let's take a look. X cubed. So we notice that our exponential expression, x cubed, is already isolated. How do you undo cubing? That's right, take the cube root. So now we know that x is equal to, what's the cube root of 64? 4. Do I need a plus or minus there? No, you don't. And it's not something you have to memorize. You just think about it logically. 4 times 4 times 4, positive 64. Negative 4 times negative 4 times negative 4 would be negative 64. So we're good with that answer. Okay, let's take a look at 13. X is being cube rooted. It's already isolated, so all I have to do is cube both sides. So x is equal to negative 2 times negative 2 times negative 2, which is negative 8. No, it's not plus or minus 8. It's just negative 8 because the cube root of negative 8 is negative 2. Negative 2 times negative 2 times negative 2 is negative 8. Wonderful. Let's take a look at 16 together. Taking a look at 16, this time our exponential expression is not already isolated. So taking a look, how do you undo dividing by 2? How do you undo half of something? You multiply both sides by 2. So now we'll have y cubed is equal to negative 64. Is this okay? It's totally fine that we have an exponent equal to negative 64 because our exponent here is odd. So now to undo cubing, I'm going to take the cube root of both sides. It's okay we're taking the cube root of a negative number because remember, a cube root is an odd index. And the cube root of negative 64 is negative 4. Perfect. So go ahead and pause me and finish 14, 15, 17, and we'll check in when you're done. Cool. Let's see how you did. X cubed is equal to 135. You took the cube root of both sides. And when you did that, you had x is equal to, and you had to think, what is the cube root of 135? So maybe you went over and made a factor tree. And when I think of 135, the first factor that pops into my head is 5. So this is 5 times 27. 5's prime, so I can stop there. And 27, I'm so happy because I already know that's a perfect cube. So I'm just going to break it into 3. 3 factors of 3. Awesome. Pick out my triple. So I know that this is the cube root of 3 cubed times 5. Pull out the 3. X is equal to 3 cube root 5. Make sure your index looks like an index and not an exponent to the 3. Cool, let's see how you did on 15. Taking a looky-loo at 15, you took the cube root of both sides. And you said, hey, x is equal to, and then maybe you had to make a quick little factor tree. Good practice for you here. 128. The first number I think about going into 128 is 16. 16 and 8. But I need 3 factors, so I need to go a little bit farther. Well, I know 16 is 4 and 4. I know 8 is 4 and 2. I'm going to stop there because notice this is a triple. So I know this is the cube root of 4 cubed times 2. And maybe you thought of different factors, but we'll all end up with the same answer. And pull out the 4. Cube root 2. Remember, it's not plus or minus because now we're dealing with cube roots and cubes. Let's look and see how we did on 17. Taking a look at 17, our exponential or radical expression here is not simplified all the way, or not isolated all the way. So first we have to simplify both sides by getting rid of this 8. How are you going to get rid of the 8? So you subtracted 8. Then we have the cube root of x is equal to 5. And then to undo cube rooting, you cubed both sides. Cubed it up. And you had that x is equal to 125. Really nice work, mini mathematicians. Okay, so we have Juliet solved a problem and she made a silly mistake. And this is her work shown to the right here. So let's take a look at her work and see, did she solve correctly? Yes or no? Okay, so she wrote down the problem correctly. She subtracted 2 from this side and subtracted 2 from that side, which is awesome because she wanted to isolate her radical expression there. And then to undo subtracting 5, she added, wait, can you touch that minus 5? Isn't it underneath a radical symbol? So this is her mistake. Cannot undo square root of minus 5 with plus 5. Must undo radical first. Okay, so let's solve this together, and we're just going to solve it from her mistake. So we're going to solve it from x minus 5 is equal to 1. So I can't touch what's inside that radical until I get rid of it. So the first thing I'm going to do is I'm going to square both sides to undo the square root. Now I have x minus 5 is equal to 1. Undo minus 5 by adding 5 to both sides. Then I end up with x is equal to 6. Awesome. So we can then verify, because it's really important to verify, 2 plus the square root of whatever x is minus 5 equals 3. We found 6 to be x. 2 plus order of operations inside 6 minus 5 is 1 equals 3. Square root of 1, it's 1. 2 plus 1 is 3. And 3 equals 3. Fabulous work. Okay, so what we're going to be looking at next is We're going to estimate a solution of x to the fourth power equals 20. I'm going to show you on a calculator how to take a fourth power. Okay, so what do we think? X to the fourth power is equal to 20. So thinking about this, if we're going to be estimating, let's think about fourth powers that we know of. So fourth power, 1 to the fourth is 4. 2 to the fourth is 16. And remember, you can think about that number squared. Down on my pens. That number squared times that number squared makes that number to the fourth. So like 2 squared is 4, 2 squared is 4, 4 times 4, 16. So we can do that again with our 3. 3 to the fourth, well, 3 squared is 9. Another 3 squared is 9. 9 times 9, 3 to the fourth is 81. Well, then we know that 20, x to the fourth, is in between 2 to the fourth and 3 to the fourth. But we have to be really careful because this is a fourth power. So similarly with x squared equal 25, x could equal plus or minus 5. We know that x is somewhere between plus or minus 2 and plus or minus 3. Which one do you think it's closer to? 2 or 3? I think it's closer to 2 also. So let's maybe like make a guess, like plus or minus 2 point, I don't know. What do you think? 3, 4, 1? I'm going to say 1, 2, 3. Why not, right? Okay, so let me show you how to do this on your calculator. So if you have a calculator like mine, you can also always like Google or how do I find a fourth root on my calculator? So if you, let's find a fourth root of a number we already know. So let's find the fourth root of 81 to make sure we know how to use our calculator properly. So of course you have this little caret button. So like if you did 2 caret to the fourth, that gives you 16. Just like we said, 2 to the fourth is 16. If I said 3 caret to the fourth, that's 81. So calculators are pretty smart how they're set up. So the inverse operation is going to be the second button and then clicking that. But notice it gave me that A and S. That means my answer from the previous. So before you press your inverse button to find a nth root, you have to say what your index is. So for us, our index is 4. We're finding a fourth root. Then we're going to press second. And we'll press that caret button to activate that xth root. See how it has that little x and that little radical? And then we're going to put what number we want to take the fourth root of. And I said we're going to do 81. I press equal. And it's 3. Fabulous. So let's do that again. I'm going to say 4. I'm taking the fourth root of 20. Second, press my caret button to activate that. I'm taking the fourth root. And I'm going to put 20 in. Let's see how close we got. Oh, really nice. And notice, of course, your calculator is just going to give you the positive because it's a calculator. It's not as smart as us. Doesn't have all those rules. So with my calculator, I found this to be plus or minus 2 point, approximately, communicate clearly, 2.11474. We'll do ... Obviously, it's an irrational number. Cool. Let's keep going. Okay, last page that we're going to be working on today. First, I want to think about taking a look at an equation and thinking about how many solutions it's going to have. So this is x plus square root of x equals 1. How many solutions does this have? Why do you think that? Let's think about the first operation that we're going to do. First thing we're going to do is rewrite the problem. Next thing we're going to do is isolate your radical expression. Notice this radical expression isn't isolated already because we have that 6 plus. So what we're going to do is we're going to subtract 6 from both sides. When we do that, you get the square root of x is equal to -5. Stop there. Some of you are going to be so into those inverse operations, you're like, square both sides, and then x is 25. I'll show you what would happen if you did that. Look at this like ugly green lime color. If I square both sides and I get x equal to 25, if I went to verify, 6 plus the square root of 25 is equal to 1. I get 6 plus 5 is equal to 1, and 11 equals 1. False statement. It's not a solution because it does not make the equation true. So you might say, but I use my inverse operations. Doesn't matter here. Here you have to take a look. From this statement right here, this statement right here lets you know that there's no solution. The square root of a number can never be negative. There's no value in the whole wide world, real number, that will ever make this statement true. Cool. So we're going to go through some equations. I'm going to solve 21, 22, and 24 with you, and then you're going to pause me and work on the others, and we'll quickly finish this up. So directions, super important. Always read the directions. Solve the equations below. Express your answer in simplest radical form. Show all your work and check your solutions. Check your answers. I even gave you a little check spot. So first of all, we need to isolate our radical expression. Should you undo multiplication or subtraction first? Always undo the subtraction first. Add 5 to both sides. From here, I have 7 square root of x plus 3 is equal to 14. From here, is your radical expression isolated? No, it's not. It's being multiplied by 7. How do you undo multiplying by 7? Divide by 7. Or, multiply by 1/7. Then you have the square root of x plus 3 is equal to 2. Can I touch that 3 yet? No, it's trapped under that radical. So we have to save it. How do you undo square rooting? By squaring both sides. Now we have x plus 3 is equal to 4. Very simple to solve from here. Undo addition with some subtraction, and x is equal to 1. Think about it. Could negative 1 also be a solution here? Well, negative 1 plus 3 would get me 2. Square root of 2. That's going to be irrational. There's no way I can take an irrational number, multiply it by 7, subtract 5, and get a whole number. In fact, a natural number. So let's do our check. 7 square root. I'm going to put empty parentheses. I'm going to put a 1 in there. Order of operations, 1 plus 3 is 4. I'm going to do my square root because that's kind of like an exponent before I multiply and subtract. Multiply 7 times 2 is 14. 14 minus 5 is 9, and 9 equals 9. We did it right. Yeah. Okay. 22. Ooh, ooh. Okay, so taking a looky-loo at 22, got to isolate that radical expression first. I'm going to get rid of that 2/3. I kind of want to get rid of the fraction completely. So I'm going to multiply both sides by 3. Make it a little bit simpler on me. Be kind to yourself, Taking a look here, 3 times 2/3 is 2, minus 3 times 4 is 12. Square root of x stays there, numbers on the outside, numbers on the outside. Multiply, simplify that radical. Equals 6. Cool. This looks a little bit more friendly. So from here, subtract 2 from both sides. We're going to get negative 12 square root of x is equal to 4. Divide both sides by negative 12. I'm going to get the square root of x is equal to, I'm going to simplify this, negative 1/3. Stop! Can you have the square root of a number equaling a negative? No. There's no number, no real number you can substitute in here to make this statement true. So this is no solution. Maybe you continued your inverse operation. You were being a math robot. You were being a math robot and you squared both sides and got 1/9. So then up here, let's pretend that you did that and you would have gotten 2/3 minus 4 square root of 1/9 equals 2. And you said, oh, square root of 1/9 is 1/3. 2/3 minus 4 times 1/3 equals 2. Okay, well, 2/3 minus 4/3, does that equal 2? No, it doesn't. So that's how, again, you know it's no solution. If you end up with a statement that's completely false in your solving process, or you'll get an answer that when substituted in makes the statement false. No solution. Okay, and I said I'd do 24 with you as well. So taking a look at 24 together. First thing we need to do is isolate the exponential, in this case, radical expression. So I'm going to subtract 7 from both sides. When I do that, I will have 2/3 square root of a over 4 is equal to 2. From here, I need to get rid of multiplying by 2/3 to isolate my radical expression. So I'm going to multiply both sides by the reciprocal, 3/2. Put that over 1 because that's what I like to do. And I will have the square root of a over 4 is equal to, the 2's cancel out, 3. Everything looks fine so far, mathematically appropriate. So now to undo square rooting, I'm going to square both sides. And we will have a over 4 is equal to 9. Let's isolate our variable. How do you undo dividing by 4? Multiply by 4. And you get a is equal to 36. Well, let's check our solution to make sure that we did this correctly. 7 plus 2/3 square root 36 over 4 equal to 9. And you can simplify this radical two ways. You could simplify inside 36 over 4 is 9, or you could simplify square root of 36 is 6, square root of 4 is 2, and either way you're going to get the square root to be equal to 3. So 7 plus 2/3 times 3 is equal to 9. And again, I'll go over that one more time. The square root of 36 is 6. The square root of 4 is 2, and 6 over 2 is 3. Or you can think about this as the square root of 36 over 4, which is 9, which is also 3. These cancel out. 7 plus 2, is that 9? Well, yeah, it is. 9 equals 9. Good job, mini mathematicians. Okay, so you have 3 more problems to do. Be really careful because you might notice that this is a 4th root. How do you undo 4th root? 4th power. Really good job. Here's a 3rd root. How do you undo 3rd root? 3rd power. Good job. Okay, go ahead and pause me, and I'll check in with you when you're done. Okay, let's see how you did. 23, undo cube rooting by cubing both sides. And we end up with b plus 5 is equal to negative 2 cubed is negative 8. Careful with your negatives. I'm going to subtract 5 from both sides. And when I do that, I get b is equal to negative 13. And of course, we have to check that. So cube root of negative 13 plus 5 is equal to negative 2. Cube root negative 13 plus 5 is going to get me to negative 8. And the cube root of negative 8 is negative 2. Awesome. So we know we got it right. Cool. Let's look at 25 together. 25. First thing you did, maybe you cleared your fraction. I decided to just add 1/5 first because we already had 3/5 over here. From here, we have 3 square root n is equal to 3/5 minus 1/5 is 2/5, so 1 and 2/5. From here, before dividing by 3, I'm going to change this mixed number into an improper fraction because that's how you can multiply, divide, add, subtract fractions a lot easier usually. So 3 square root n equals 1 times 5 plus 2, 7/5. From here, I'm going to divide both sides by 3. Remember, when you divide by a fraction, you're really multiplying by the reciprocal. So I'm going to show multiplying by 1/3. And again, that's just because these 3's cancel out. So now you'll have the square root of n is equal to 7/15. And how do you undo square rooting? We take the square of both sides. And we will have n is equal to 7 squared is 49. And 15 squared is 225. My answer key is different. Oh, you guys, I should have added here and I subtracted. Whoops. Sorry about that. Hope you caught it before I did. Let me grab a paper. We'll just pretend to rewind. We all make mistakes. I tried to rush to make it a shorter video. Sorry about that. Sorry. Okay, let's keep going. 3 square root n minus 1/5 is equal to 1 3/5. I'm going to add 1/5 to both sides this time. Thank you for your patience and understanding. Hopefully you were yelling at video bar to stop. From here, you'll have 3 square root n is equal to 1 4/5. 3 square root n is equal to 1 times 5 is 5 plus 4, 9/5. Now, from here, I can take a third of each side. And I will have square root of n is equal to 9/15. I'm going to simplify 9/15 just so I have smaller numbers. Square root of n is equal to 3/5. Now I'm going to square both sides to isolate my variable and undo square rooting. And n is going to equal to 9/25. Hopefully that's what you got too. So now we're going to do our check. And we have the original problem, 3 square root 9/25 minus 1/5 equals 1 3/5. From here, we're going to simplify order of operations. This grouping, square root of 9 over 25 is the square root of 9, which is 3, and square root of 25, which is 5. Minus 1/5 equals 1 3/5. This ends up being 9/5 minus 1/5 equals, let's turn this into an improper fraction. We get 5, 6, 7, 8, 8/5. 9 minus 1 is 8. 8/5 equals 8/5. Woohoo! We got it right. Had to change a little bit of things, but it's okay because we persevered. Okay, one last problem. Then you can tell I think I'm getting a little hungry. Let me plug in my computer also so it doesn't die. Fixed. Okay, so 26, last problem you had to do. Quickly go through this. We're going to take the 4th power of both sides because, oh my gosh, you guys, you have a 4th index here equaling a negative number. Is that even possible? This is no solution. Maybe you noticed it already from there, or maybe you kept going. So let's keep going just in case. You'd have 3x squared minus 1 is equal to negative 1 to the 4th power is positive 1. Then I'd add 1 to both sides, and you'd have 3x squared is equal to 2. From here, I would divide both sides by 3. To undo multiplying by x squared, you need to isolate the x squared before you square root. So now you'd have x squared equals 2/3, and you'd have to take the square root of both sides. From here, you know it's a plus or minus. Oops, you don't need on this side. And then you'd have to rationalize your denominator. So you would have to multiply both sides by square root 3, top and bottom, not both sides, numerator and denominator. That would be plus or minus square root of 6 over square root of 9, which is 3. And then you'd have to check this. So if you went to check this, you should end up with a false statement. Fourth root 3 plus or minus square root of 6 over 3 being squared, all minus 1 equals negative 1. Well, luckily we're squaring this, so this ends up being fourth root 3 times, we don't have to worry about the negative anymore since we're squaring, it's going to become positive, 6/9, square root of 6 squared is 6, 3 squared is 9, minus 1 should all equal negative 1. Well, 6/9 is really 2/3. 2/3 times 3 is 2. So this is the fourth root of 2 minus 1 should equal negative 1. Well, is the fourth root of 1 equal to negative 1? No. So that's a false statement. So again, we're confirmed that this is no solution. Thanks, mini mathematicians, for all your hard work and your perseverance. Again, this was 6.2 F lesson. Best of luck on your homework. Remember, you can always email me or ask a question in Google Classroom if you have any questions. Have a wonderful rest of your day. I'll talk to you later. Bye.